Hello, everybody. Welcome. And this is Desi BJ. I'm a North-South National Team member and a coordinator for the webinars. I'm glad to see you all here today. We are pleased to have another MTP session, this time for computer science, which is one of the newest contests we have started for the regionals. We have a few of the past winners and accomplished youngsters here with us to talk to you and then share their experiences with you. We call this as Meet the Pro type webinar sessions for the youngsters to come and talk to you and then clarify your questions or doubts. We already had several sessions in the past in spelling, in the CAB or brain, science and math, and you can watch those videos or recorded sessions in our YouTube channel. We have specially created a playlist for that. And let's go on with the current computer science pros. Thanks for your continued support and attending this webinar. Finally, our regional contest registrations have started, and we'll be sharing the contest level information, contest prep club, etc. In the website. Please go visit our website northsouth.org and then register for those contests. And I thank you very much for your continued support for all our activities. Thank you for listening to this, and let's start with the program. And let's move on with the program. We have Dr. Krishnan Gauri here, Chief Education Officer, who would be moderating the session and introduce you to all the panel members. And Dr. Krishnan Gauri is currently a Chief Academic Officer of North-South Foundation. He has been a North-South volunteer since 2005 as a parent volunteer, chapter director, and national team member. He's also a math coach and always curious about learning. Professionally, Dr. Gauri is a building science expert, works as a building performance consultant for high performance building design and net zero building design. He's a civil structural engineer specializing in computer applications for the construction industry. When he is not working or busy with the North-South activities, he plays tennis and he's a certified USDA official, and currently he's learning to play harmonium. So, thank you, Dr. Krishnan, and then the floor is yours. You introduce the other core members too.
Sure. Thanks, Daisy, and welcome to all of you for this computer science contest Meet the Pro session. I would like to thank Daisy for coordinating all this and getting us together here, and also to Anju Balachandran from the core team to help us and keep us straight with any answers we are providing you. Thank you, Anju. We have 5 very accomplished pros who have been competing: Pranav Ramesh, Bhaumik Mehta, Shreya Mughal, Satvik Salvan, and Badrinath Konidala. I hope I got that correct. What I plan to do is to introduce each one of them and then have them share their experience with the computer science contest, and hopefully convince the 57% of you that are still thinking about registering, and also answer any questions if you're registered and wondering what you'll be doing in the contest. So here we go. The first one will be Pranav Ramesh. Pranav is a high school senior from Connecticut and has been volunteering with the North-South Foundation for over 4 years, proctoring at contests and serving as a programming coach. He has been coding in Python and Java for the past 8 years and in Swift for the past 5 years. Wow, that's a lot. He has developed and published 5 iOS apps to the Apple App Store under his educational app startup, taught beginner and advanced programming courses to high school students around the world, and written and published 2 beginner programming books, the Python Starter Pack and Java Decaffeinated, on Amazon. Pranav is also an avid competitive programmer and has placed in the USA CO Silver Division and won third place internationally in the American Computer Science League World Finals, and won third place nationally in the North-South Foundation Computer Science Bee. Outside the competitive environment, Pranav enjoys creating computer vision, machine learning projects, and playing classical piano. That's awesome. Pranav, do you want to share your screen and get started?
Okay.
Sure. Hey everyone, I'm Pranav. We'll just get my screen shared in a second. Could someone give me the screen sharing access?
Yeah.
Okay. So yeah, I'm Pranav. I'm a high school senior at South Windsor High School in Connecticut, and I'll just be going through like 2 to 3 minutes about some of my tips for you, some of the things that I've done, things that might help. So we'll just get started with some of my experiences. So as Dr. Krishnan said, I'm a senior and I have this language experience. So I've been coding in Python and Java for a very long time. And I've also been coding in Swift. So that's an iOS app development programming language. I've been doing that since 8th grade. And I just started C++ a few years ago. I've been meaning to get into that. So that's currently underway. So a little bit more about me, my programming experience. I think we went through a little bit of this, but primarily I've done a lot of iOS app development. And in particular, I've published so far 5 apps, including GeoScholar, a Geography Bee preparation app. So you can use it for all sorts of contests like the NSF Geography Bee. Scholarly, a personalized GPA calculator, and then GSEF Official, an economics resource platform that contains quizzes, podcasts with notable economists, and so on and so forth. And then Gene Express, just a small app I created, a gene expression simulator, polypeptide chain predictor. And then ReadSpeak, another fun accent translator app. So a lot of different things that I've done in this context just to simulate like a freelancing kind of application of iOS app development. Now, in addition to app development, I've also done a lot of other things, in particular relating to the improvement of technical literacy. So all of this is falling under course creation and video tutorials. So I've been doing that for the past few years. So all of that falls under Code Savant, which is my technical literacy foundation or organization that I created to teach beginner and advanced programming. I've taught a bunch of beginner Python courses and intermediate data structures and algorithms courses. And I've also published a bunch of YouTube videos. You can check this link out. I think the slideshow will be shared with everyone at the end of this presentation. So if you want to look at that as well. And then I've also published 2 books, the Python Starter Pack and Java Decaffeinated. These are meant to get students involved in programming if they are beginners. So it'll teach you all the fundamentals of Python and Java in a problem-solving manner. So you'll be solving a lot of different problems. And I felt that that was a great structure for people who are interested in doing computer science. Now, I've also been doing a lot of other things like computer vision and Arduino. So I recently got really interested in computer vision, created a lot of projects. So one of them was a table tennis game tracker. So you set up a camera, it tracks your game, and then it scores, and then it analyzes the players, figures out the best strategy to beat each other, things like that. And then as part of a program I did last summer called the University of Pennsylvania Management and Technology Summer Institute, I created Pillola, which is a smart, secure, portable pill dispensers for seniors in assisted living facilities. So a little bit of entrepreneurship with computer science as well there. And I've also done some competitive programming, not too much because that wasn't too much of a priority. So I've done USACO, I've placed in the silver division, haven't really gone for the next levels because I've been more prioritizing the rest of this. I've also done, as Dr. Krishnan said, the American Computer Science League, where I placed 3rd place internationally. And then there are some other things that are not really relevant to this, but they're there as well. So I think one thing to emphasize as part of your journey into computer science is the coursework that you take, specifically relating to maths, sciences, and computer science. And so with computer science, some courses that I've taken that I think you should take as well are AP Computer Science Principles. So this is a great course offered by College Board to get right into the foundations of computer science. It's more theoretical than it is practical, but you will do a lot of practical coding. And then in my 10th grade year, I took AP Computer Science A. So this one is really a course that gets you kickstarted into the Java programming language. It's a great introduction to that language. You learn a lot of new concepts. It's a very rigorous course, but definitely should take it. And then one course that I took outside of my school was Harvard Computer Science Intensive Introduction to Computer Science. So I took this course just because I wanted a little bit of a challenge. This is definitely another great introduction to Java programming, as well as it provides insights into data structures and algorithms. So if that's something you're interested in, you can pursue that as well. And then mathematics. Math is a very important part of computer science. It helps you solve all the problems, allows you to like really understand what you're doing in terms of all the theory. So in 11th grade, I've only left the important ones here, but in 11th grade, I took AP Calculus BC. There's AP Calculus AB and BC. Both are very good courses, but you should definitely pick between which one you would feel is best suited for you. And then after this, I would also recommend you start looking at a discrete math course, because discrete math is very important with computer science. There's a lot of things you learned there, proof writing, number theory, all of that is very important. So I took this course, CS20, as part of Harvard's computer science curriculum. Definitely something you can look at. And if your local community college also has a discrete math course, definitely take a look into doing that. It is a tough course. Discrete math is a tough subject, but it's well worth it. You definitely look at that. And then multivariable calculus. This is very important, especially if you want to do anything related to maybe robotics or physics, something like that, as it applies to computer science. So definitely think about taking multivariable calculus. I am taking that this year, and it's very fun. And then I also took linear algebra and real analysis course. Linear algebra is also extremely important with computer science, especially if you're doing things like transformations or if you're doing anything related to robotics or graphics. Very important. So definitely take a look at doing a linear algebra course if you're able to. Now with science, I've included this as well because it's like somewhat important. Like you should still be able to see how you're able to apply computer science in other aspects. So these were the ones that I took. I took AP Biology, AP Chemistry, and I'm currently taking AP Physics C, Mechanics, and Electricity and Magnetism. So I would say that physics is the most important science that you need for computer science. It's the most, I guess, used in terms of application-wise. Biology and chemistry are definitely important if you're thinking about computational biology or computational chemistry, something like that. So that's the coursework. And of course, all this will be provided to you at the end of this seminar. Now, general tips for computer science. So how do you get started? Well, you need to make sure that you're able to master at least one text-based programming language, because those are the most popular. And I would say you take a look at Python, Java, and C++. One of those is probably your best option. I started off with Python, and then I transitioned to Java. And both are very good. And so I've developed a fluency, especially in Python. And it's important to have that, because if you're trying to create any project, having that fluency is going to really accelerate that process. And so while you're learning a programming language, in my opinion, the best way to cultivate your learning experience is to practice a bunch of problems. And there's this one really good website for any beginners, and that is called Project Euler. The link is here, and it'll be provided at the end of this webinar. And so there's just a bunch of problems, I think 600 or 6,000 or so, where it starts from easy going to hard. And it's just, you learn how to do various optimizations in your code, how to just do general syntax. It's a very good site. And then HackerRank and LeetCode are also very good for both learning and practicing programming. And once you get past the beginner steps, you can also practice advanced things like data structures and algorithms. And it's also very helpful for interviews. So these are the two links for that. And then if you're more interested in competitive programming, I would say that a good source that helped me get started was the CSES problem set. There are a bunch of competitive programming problems here, and it's just good practice. They're all categorized, so you can get a good idea of that. And then other competitions as well, like the USA Computing Olympiad, American Computer Science League, Google Kickstart, Google CodeJam, CodeChef, Codeforces. They're all very good for getting you into computer science in a competitive aspect. Now, aside from the competition part of it, you also want to make sure that you're able to apply your skills in diverse scenarios. So let's say maybe simple projects you could do, like to-do lists or calculators or tic-tac-toe or other games. And then you can build off on that to create more advanced projects like alarm clocks, or maybe you could make mail merging or sending custom emails, things like that. Just utilities to help you with your daily processes. And then one thing I would say is the most critical is figure out what you really like in computer science. So maybe it's going to be iOS and Android app development. Maybe it's going to be web development. Maybe it could be something else like computer science, machine learning, or competitive programming. Whatever it is, find that specialty and really get into it. Maybe even computational biology, something like that. If you're able to apply computer science in some very niche sector, then you're going to be very invaluable in that sector. So those are my tips for computer science, and I hope that was very informational.
That was impressive, Pranav. And you're a high school senior.
Yes.
Man, I can't imagine getting half of what you did in my 30 years of career. That's impressive. Very good.
Thank you.
Thanks for sharing your experience as well as tips. We will probably come back to you with more questions later. And now we'll move to Bhaumik Mehta. Bhaumik. He's a sophomore at West Windsor Plainsboro High School North. He has grown up doing math and coding and enjoys learning new concepts at contests. He's currently invested in machine learning, a bridge between his two favorite subjects. He's a two-time US AJMO qualifier, director of Python curriculum at Codivate, and US ACO Gold member. He also got top 6 in the honors of Computer Science B in 2021. Aside from these aspirations, he also enjoys running and playing Nintendo games. Bhaumik, do you want to share your screen? Can you?
All right, yeah. Can everyone see my screen?
Yes.
Yep, go ahead.
All right, cool. So, hello, my name is Bhaumik Mehta, as previously mentioned. And yeah, I'll just take you guys through my tips on computer science and my journey. So this is more on computer science with Bhaumik Mehta. All right, so a little bit about me. You've already heard a bunch of things, but yeah, I really love math and I really love coding. And the combination of the two is basically what I invest all of my time doing. So yeah, I think something really important is you need to have a passion for whatever you're looking into. And the fact that all of you guys are here in this CS webinar means that you have some sort of interest in computer science. So it's really important that you develop this passion and continue to invest time into it, learn more, and engage yourself into it. So the way I engaged myself into computer science initially started with math. I didn't know any computer science, but I was doing a bit of math, and I often came into scenarios where I needed to look at something or I needed some more understanding, but I just didn't know how to do it. So that's when I started looking into CS. I learned some basic syntax and started to apply them to my math problems. And this was the first really good application of CS that I found. It really helped me understand more about math, and this enriched my thinking. So as you're going to see throughout this presentation, CS has a lot of applications, but I think the best application is for you. And CS can really help you invest and learn more about this other things that you're doing. So after I realized that CS was very useful, I started learning languages like Python, Java, C++, JavaScript, and so on. And once I learned all these languages, I started applying these syntax and different functionalities into various other parts of my life. So not just math, but others areas of interest as well. Currently, I'm invested in machine learning and competitive programming. With machine learning, CS is a great way to take all of the theory and the math side of things and bring it into the real world. And there's a lot of places where you can apply machine learning as well. For example, when you go on YouTube and search a video, YouTube uses a machine learning algorithm to decide what it's going to deliver to you. And machine learning is very broadly applicable. It's used everywhere. And this is just one branch of CS. There are a lot of different branches of CS that are used around the world. Another thing is competitive programming. So competitive programming looks more at the algorithmic side of things. So let's say you have a problem and you're not really sure how to do it the best way. That's what algorithmic thinking is all about. It's about how can I best solve this problem. So let's talk a little bit more about the benefits of CS. To start, CS is literally everywhere. The fact that you're on this webinar right now is possible due to CS. So if you learn CS, it'll greatly help you no matter where you go. Even if you're not that interested in CS, learning CS can help enrich some of the things you do. And like I said, you're going to find applications of CS in various places. For example, with math, I never knew that CS could help me learn so much about the problems I was facing, but it really did. So to get more into specific applications of CS, you can learn more about the internet. So like networking, protocol, and how data is transferred between you and someone else. For example, you're sitting at your computer at your home right now. How are you able to communicate with me, who is probably very far away from you as well? There's a whole branch of CS related to this as well. It's called cryptography, and cryptography essentially looks at how we can be secure about the data we're transferring from one place to the other. And then there's a lot of applications in modeling as well. So let's say you're given a problem and you're not really sure how to solve this problem or how to work with it. CS can help you model the scenario. And once you have a computer model something for you, things get much easier because computers can work much faster than us. They can do calculations much faster than us. And this means that once you've modeled a problem, computers can analytically compute solutions for you that you may have not been able to do before. So that's also very useful. Another thing is algorithms and problems. So similar to modeling, this is a bit of a different setting where you have a specific problem, but there's many different ways to solve it, and you're not really sure what the best way is. So this relates to something called time complexity, which is how long will it take this algorithm to run? And this is a branch of CS which focuses on your creative thinking skills, where you have to think about how can I create a solution that works fast and solves the problem at the same time. Finally, there are also a lot of technologies that use CS. For example, as we talked about, the fact that you're sitting at your computer screen right now and hearing the things that I'm saying, that's part of CS. And there are various other technologies that rely on CS as well. So learning computer science will help you no matter where you go. And I think that's a really good motivation to get started on learning CS. So now I'll go into some tips for CS that I have. So CS can be very daunting because it's different from the other things you may have seen in school. Pranav did talk about some courses you can take in school related to CS, but CS is a very vast field. And in high school or in middle school, there aren't as many opportunities specifically within school to learn CS. So CS is a very self-directed type of environment where you have to invest time yourself to learn about it. And this just goes to show that if you have a passion for CS, you can go forward with it. So that being said, here's a timeline I think you guys can follow that'll really help. First thing you should do is learn your language syntax and learn the basic programming principles. This is really important. It's not just about syntax, which is specifically the keywords and how the code is written, but it's also about the ideas behind why these decisions were made and the ideas behind fundamental constructs of programming. So going further into this, you can start by learning mainstream languages. I'd also recommend starting with Python because Python is very easy to learn. It is high level. Once you learn Python and some of the constructs that have governed Python, some reasons why people made decisions there, you can start learning more lower level languages like Java and C++. And these languages are typically faster than Python as well. But all these different languages have different purposes. So if you're feeling overwhelmed with all the different things you can do, don't worry, just take it step by step. And yeah, as you're learning these languages, make sure you focus on learning the coding design and the reasons behind why people made these choices. Some specific links I can refer you to is on YouTube. There's this YouTuber called CodeCamp, and he hosts free tutorials, in-depth tutorials on various different languages. And he goes in depth with all of the different things that there are about the language. So it's very useful to use his videos on YouTube. They're about, let's say, 5 hours long per language. So if you're looking to get started on language syntax, you can just break up his videos into different chunks. And then, yeah, just get started with it. Another place you can go is Udemy. There are plenty of really good courses on Udemy. Some of them are free, some of them cost a little bit of money. But it's usually not that much, usually under $10. So for the cost of a coffee, let's say, you can get started with coding. and learn a lot about how the various languages work. Another one is W3 Schools. This is another free resource that is online. This is basically a website someone has curated that has in-depth examples of all of the different aspects of, let's say, any language like HTML. So any of these resources work. And if you want, you can also search and try to find more resources. It's all up to what works best for you. So once you've learned these languages and you've learned the syntax, you have a method, a tool that you can use. And now it's time for you to apply these tools. So you can focus on many different areas. For example, there's the algorithmic side, which once again, you have a problem and you want to figure out a solution. And now you have to implement that solution as well, using the language that you've learned. There's also the web dev side where, let's say you want to create content for someone and you want to display this content to millions of people around the world. You can learn web development and try to display that content. Similarly, you can go with app development, which is basically the same thing, but on your phone or on a tablet. And then there's personal use. This goes back to me and my math use. There are lots of places in your life where you will need CS to enrich your understanding. And you can apply what you've learned there. So going more into the algorithmic side, there are a bunch of really good resources online and contests online that you can use. So one of them is USAGO. This is the most mainstream competitive programming that's out there. And you can get started with their USAGO guide, which will take you through the constructs of algorithmic programming and how to think in that mindset. From there are a lot of contests you can apply this to. USAGO is also a contest, by the way. For example, there's the American Computer Science League, there's Google Kickstart, there's Codeforce's HackerRank, and even the NSF contest that's going to come up soon, which you guys can consider registering for. By going to these contests, it enriches your understanding and helps you also learn more about the language itself. They're also really fun experiences. Dealing with problems is hard, and once you figure out solutions to them, it's really validating, and it gives you some justification as to why you spent so much time on this. Codeforces and HackerRank also have a wide repository of many different problems that you can apply yourself to, and they also range themselves in terms of difficulty. So you can start at the easy difficulty and then go on to the harder ones. So it's also very well paced. And then finally, I'd encourage you to meet others. It's important to reach out and network. Don't just stay bottled up within yourself. Talk to your friends about coding and see what they've done. Maybe you guys can motivate each other, challenge each other to, let's say, do something within a certain time frame. Maybe you guys can share projects you've made and collaborate on different problems that you may have experienced. The main thing is you should enjoy programming and do things that relate to you. So as long as you keep these tips in mind and enjoy the experience, I think you're going to have a great time with computer science. Thank you.
Thank you, Bhumik. That was a lot of very good tips as well as resources for our participants. I see that our next speaker, Sharia Mughal, is also from the same school as Bhumik. Is that right? Okay. Yeah. So Shreya is a senior at Westminster Plainsboro High School. She loves math and computer science and won 4th place North-South Computer Science B Nationals. She's a national cyber scholar and previously led her team to the 1st place in the New Jersey State and tied for 7th in the nation. She's the vice president of the school Computer Science Club and contributes as a problem writer for the high school CTF, which they host. She has reached the gold tier at the USACO, and she received the MIT X Philosophy Award for the papers she submitted for the course Paradox and Infinity. She's looking forward to joining MIT this August as a CS math major. And Shreya will also bring all our audience up to speed with all the rules of the computer science NSF contest, right, Shreya?
Yeah, so should I do it now or after everyone has been introduced?
I think you do it afterwards. You just introduce yourself now.
Right. Okay. So you will do that at the end. That's better. Thank you.
Okay.
Go ahead.
Yeah, I don't have like a presentation like everyone else, but I will say that I think Vivek mentioned it's good to take things step by step when you're like trying to learn something in a field that is as vast as CS. And one of those steps can be to register for the North-South CSP and do the coaching, because honestly, the fact that all of you like joined today probably means that you had some like ties to North-South in the past. And I think that like doing CS with friends, especially like in the contest format, will motivate you to actually learn things, because it's easy to like put things off for later. If you sign up for the contest, you're like guaranteed to have some motivation to study these concepts, so do it.
Okay. So we'll wait for your presentation on the contest itself towards the end. Our next speaker will be Badrinath Konidala. Badrinath is a sophomore at Cypress Bay in Florida.
He's not here today, Krishnan, but yeah, you can.
Pardon?
He's not here today.
Oh.
Badri is missed.
Okay, so we'll go with Satvik Selvan.
Yeah.
Okay. Satvik Selvan is currently a senior at the American Heritage School in Plantation, Florida. His passion for math and computer science has led him to participate in many competitions in these areas. He has been competing in the AMC 10 since 6th grade and was able to qualify for the USA Math Olympiad last year. He has also competed in the USACO and is currently in the Gold Division. With the competitive programming team at his school, he has placed in many individual and team contests, such as those held by UCF, Stetson University, and Lockheed Martin. Since first grade, he has been competing in various North-South contests in the math, science, spelling, and vocabulary categories, qualifying for nationals every year since. As a freshman, he was able to participate in the APNA program, going to his hometown in India and teaching children various concepts in vocabulary and math. In his free time, he enjoys doing interesting math and competitive programming problems, playing video games, and practicing the drums. So let me make you a presenter, Satvik.
Okay, so I think everyone can hear me now.
Sure.
So yeah, this is just my introduction, and I'm hoping that after I show this, you'll kind of have a better idea on what you can do to get started with computer science. And so here's some background about me, right? So I'm a senior at American Heritage School in Broward, and one thing that's really important is, as Pranav said, is you need to have a solid foundation in terms of what classes you take at school. So for me personally, some classes would be the AP Computer Science classes. There's AP Computer Science A and Principles. Principles is a more general overview of computer science and programming, while Computer Science A specifically focuses on Java, which is a widely used and really useful language. And in terms of math classes, the AP Calculus AB and BC classes are a really good place. And if you're looking to delve deeper into computer science, other classes like multivariable calculus, differential equations, linear algebra, those kinds of classes are useful. And some classes that I personally took online were those offered by Stanford, Princeton, and Harvard on websites like edX and Coursera. And so in terms of my experience with programming, I've worked with Java, Python. In terms of data analysis and machine learning, I've also worked with MATLAB and R. Some of my awards, I am a USACO Gold qualifier, a 4-time AMY qualifier, and a USAMA qualifier. And so, as you can see, being a strong CS person relies on a solid math foundation, and just some other of my CS involvement. I did an internship for a company called Accelerate, and what I did there was mainly with robotic process automation. And then currently I am doing machine learning research on causal inference. So some of this will overlap with what, Pranav and Bhaumik said, but just, to go over it again, some languages you can get started with are Java and Python. For Java, the AP Computer Science A course is a good resource, but, as Bhaumik said, you can find videos on YouTube, and there are also courses, on websites like Coursera and edX, which are really useful because those courses are essentially taken straight from colleges. So by doing those as a high schooler, you'll kind of get a head start even before you go to college and you go into the real world. And then for Python, a really good course is Harvard's CS50, which also leads into their CS50 AI for those who are interested in that. And in terms of practicing, right, that's a big thing in terms of mastering your programming language. There are a lot of resources. Just to name a few, you have CodingBat. It's a website that has practice problems for both Java and Python. Then, some stuff about competitive programming, which is where I focus a lot. Some websites are USACO Guide, which, as per its name says, it's a really good resource to prepare for the USACO. And HackerRank, LeetCode, and CSES are all very useful websites too that have a lot of practice. And the big thing with competitive programming is it has a strong focus on algorithms, right? And for any CS majors or people involved in the CS field, you probably know that to get into companies you have sort of interviews, and as part of the practical interviews for a lot of companies like Google and Facebook, they often use problems that are very similar to competitive programming. So by learning and becoming familiar with algorithms, they can really give you a solid foundation in computer science. And in terms of where you can go with computer science, right? As Bhaumik and Pranav said, there's a lot of areas that you can go into, whether it's combining it with another field, solely focusing on algorithms. There's web development, machine learning, and a good place to explore this is Medium. And so what it basically is, it's a website that has a lot of articles on a variety of subjects, and it's really useful, especially if you are looking to get into CS and just want to explore, a lot of the current things in computer science. And I think another big factor is doing computer science at your school. So, there's really two options here, right? So you could, if your school already has a, club for computer science, you could look into that, join it, because, as Bhaumik said, computer science is really, it's more fun, and you get better at it by collaborating with others and, by working with others. And if your school doesn't have a club for computer science, a really good idea would just be to start one, because there are probably others, at your school who are probably also interested in computer science. And by creating a club, right, you can create a sort of community where you all can work together. And having a place at your school also helps in terms of participating in various competitions. For me personally, in Florida, where I live, there are a lot of competitive programming competitions hosted by many colleges. Just to name a few, there's ones hosted by UCF and Stetson University, FIU, USF, and but there are also competitions, that are global, right? And so you have USACO, which is probably the most widely known one, but there's also websites like Codeforces, where you can find a lot of competitions, and Google and Facebook also have their own annual competitive programming competitions, as well as Lockheed Martin, right? They host a competition yearly that's available globally, which is also, you know, similar. It's a competitive programming competition. But, you know, other branches, right, of computer science, for example, hackathons, right, where you're able to apply a lot of different aspects like web development, you know, robotics, and you can be creative, right, with what you create. So that's kind of like, it's a more real world application where you're given a challenge. And there's also CPS, or capture the flags. And these mainly deal with, you know, sort of like cybersecurity and cryptography, and so that kind of stuff. And then of course, you know, there's machine learning and projects that you can do in machine learning. And so speaking about projects, that's really the most important thing, no matter what you do, is constantly exposing yourself to computer science and, you know, interfacing with your language or languages will both keep you motivated and also improve your expertise, especially if you're a beginner. One thing that you might find really motivating is learning a concept, let's say how to use lists. And by creating projects, you'll be motivated, and it'll also be like a sort of tangible result of, you know, the progress that you've made so far. And, you know, through these steps, right, learning a language, you know, doing projects and finding peers and places where you can practice, you'll be able to prepare yourself better, you know, no matter what field of computer science you decide to go into. That'll be it. So I hope that was informative.
All right, so now we'll get back to Shreya to get the information about the computer science week. But before Shreya, you present, I wanted to share a story with the audience. So when I started my learning of computer programming, this is now in 1980. It's called Fortran 77 in India. If any of you have heard of Fortran 77, it used to be a programming language that's taught in India. But we never had computers. We were taught computing, and we were asked to think about how to, you know, write a program to solve certain problems, simple problems. And that's what we will be asked in the exams. So when I came to Canada, that's where I started my first rendezvous with computers, if you want to call it. We had to punch these in cards. So I had written my first computer program, I think about 12 lines. And it's a very simple one, and it is supposed to work. So I gave the card deck to the attendant, and he will run the job, and he will give me the results. So he ran it, and then he said, you have to put a period after the job name, and then only it will process the code. So he gave it back to me. And I went back and updated the job card, typed period, gave it to him. And he said, no, we have to put a period at the end of your job card. You haven't got that. So I said, I have put the period. Apparently, I typed period. I didn't know period means it's a dot. So the full stop or the period is the terminator for the job number, which I didn't know it. So it took me almost 3 or 4 tries just to get my first thing done. Ever since, I have done maybe about 12 or 13 different programming languages, but what I learned from Fortran did not change. So I think any language you pick, you're going to be fine as long as you learn the concepts. So with that, I'm going to let you take the floor, Shreya, go. Are you a presenter?
Yeah.
Okay. And audience, if you have any questions so far for the presenters or for Shreya, go ahead and post them as well. Go ahead.
Yeah, sounds good. Sorry, it wouldn't let me unmute until I clicked the not yet button. But yeah, thanks for the interesting story. I can only imagine how like would be to learn programming without actually programming a program until like you got to Canada. So.
I wonder you guys haven't even seen a floppy disk, 1 megabyte, leave alone the punching cards.
Is this visible?
Yeah.
Awesome. Okay, so we're going to go over contest info right now. So that'll be like registration, rules, registration, and preparation. Okay, good. So contest info. As you all may know, this computer science fee is for grades 9 through 12. Currently, there is like only one level, but there might be more in the future. And the people who will take it will take a 45-minute 30 multiple choice question test, and that will be the only phase in the contest. Okay, good. So more rules. This will be an online test, so electronically graded. You'll get 1 point for a correct answer and none for an incorrect answer. In particular, there will be no partial credit and no penalties for guessing. And since there's no partial credit, you don't need to upload any scratch paper. But you can use blank sheets of paper, pens and pencils for scratch, and you cannot use any other form of external help. Okay, good. And if you do well, you might be invited to nationals. This is not based on the ranks of like that you achieve in the regional contest. It will only be based on your total phase 1 score and the phase 1 scores of everyone else in the nation. So in particular, if you have any like regional tiebreakers, those will not have any bearing on your invitational to finals. Okay, good. And if you want more info on like rules and stuff, in particular like tiebreakers or like how winners and ranks are determined at each level, then you can go to that link. And I think I'll have a screenshot of this later. Okay, registration. So registrations have opened. You can go to this link in order to get there. It's also on the website. I think we'll have that on the next slide. And registration will generally close 2 weeks before the contest date, and different chapters will have different deadlines, so make sure to do it quickly. Okay, so this is a screenshot of how to get to like registration for computer science. So you can go to the US activities dropdown and then hover over contests, and then you'll see regionals online. And you can click on the computer science regional contest. I don't know if you can see it, probably can. There's an Easter egg somewhere on the screen. If you find it, right next to it will be register online. You can probably use a laser pointer, but it was more fun to say, look at the Easter egg. Yeah, so there's the register online button. So you would click on that and then it would take you to the registration site. Okay, great. Preparation. So there is a bunch of resources on the North-South site with respect to like preparation for the computer science bee. So there's a resource list in the preparation tab. So if I go back, there's a preparation tab here and a syllabus tab here. Each tab will have different resources that you can use. Under the preparation tab in particular, you will have resources such as ABCS, which people have mentioned previously, like the other presenters. There's also Khan Academy and 2 books that are mentioned in this tab. One is for Java and one is for Python. And obviously, the other presenters will share their slides after the session, so you can see any resources that they have compiled. Yeah, okay, so there's also North-South coaching, which is the big bullet that I did not mention yet. So this is like a screenshot of how you might get there. So you go to US activities and then coaching, and then there's a computer programming section, and you can see it here. Yeah, there are no Easter eggs here because everything's on the same, like in the same area and already highlighted, but yeah. Okay, and so there are some problems if you go under, I think, syllabus. So I will click on it and then we will see some sample problems that you might see, or like problems that you might see on the CSB for North-South. Okay, great. Okay, so should I read them out and then they'll tell me in the chat what they think the answer is? Or
yeah, try maybe 1 or 2 of them, not many. Go for it.
Okay, got it. Okay, so a palindrome is a string that is spelled the same forwards and backwards. The following code tries to check if the given string is a palindrome or not. It does not work properly when the input is given as a mixed case string. So for example, H, capital A, and then lowercase pby or something like this. Okay, so the Java code has some code. Python also has some code. And there are a couple of options on how we can fix the code. So we can maybe convert P to lowercase before line 2. 2, convert P to uppercase before line 2. 3, change condition on line 2 to P : -1. Okay, so if you can read Java or Python code, you can understand what this means. And 4, change the condition on line 2 to something else. Okay. So the answer choices are A, only 1, B, only 2, C, both 1 and 2, D, all options work, or E, none of the options work. I can't see the chats, so please tell me if people say something. At least I don't think, yeah.
So while we're waiting on the chat for responses, I was wondering if Anju wants to say anything about the computer science contest questions in general. Can you speak?
Yeah.
Sorry.
Hi, Krishnan. Thanks. Good afternoon, everyone. I'm Anju Balachandran, and I am a chapter director for Marlborough, New Jersey chapter, as well as the regional director now for the Mid-Atlantic region. Welcome to all of you for so this computer science contest, as our panelists have already said, this is the first time we are doing it as a part of regional contest, and we all are looking forward to you all participating in this contest. So basically all the rules and syllabus, they are there on the website, and the students will have to basically know either Java or Python as their programming language. So the questions that will be there, they are multiple choice questions, and both the versions of the question, like it's there either in Java or Python, so that you can pick one and select the answer accordingly. And so the questions are distributed as like few are easy, then intermediate, and then a couple of them are the hard questions. And I think there are close to 30 questions, and it's like 45 minutes.
Yeah,
Yeah.
Shreya, you want to go over
Oh,
that
yeah,
one?
sorry. Yeah, it is 30 questions in 45 minutes.
45 minutes, yes. And all these panelists have already told you what to use for the preparation of this contest. So it's basically, it covers your AP computer science course that's taught in the high school.
Great. Thank you, Anju.
Yep.
Shreya, we are seeing answer as C, I think.
Okay, good. Yeah, whoever said C, right?
Yeah.
You can either convert P to lowercase or convert P to uppercase, because if it's mixed case, you don't want to have invalid answers because of that. Okay, good. Should we do another one, or?
I think we have a little time, so you have provided them the link, so let them try it. We have several questions on the chat, so we'll start with it. The first one comes from Dr. Chituri for the panel. Can you say a few words about gamification? Maybe Pranav, you want to start us? Gamification.
I'm not too familiar with that, so I think if someone else wants to answer that.
Yeah, gamification. Basically trying, Dr. Chituri, if you can unmute yourself, can you ask the question maybe? Yeah, go ahead, Satvik.
Yeah, so let me so gamification, right, for those who don't know, is basically just you have a game, right? A game, usually you have, competitions, you have points, your rules and that kind of stuff. And so gamification is just when you apply that, right, in other areas. So I think NSF, right, this competition is just a really good way, an application of gamification, because it takes something like computer science, right, like a concrete, like just a real world field, and it turns it into a competition with points, and so that kind of gives more motivation, and also it just makes it more fun to get involved into computer science.
Okay, Anybody else want to?
Yeah.
Wait, I was wondering, so was the question just about gamification or like?
Yeah, about gamification and its application, I guess.
In context of the contest, like
Yeah.
the okay, so as I think as Satvik mentioned, he explained pretty well. It's like trying to engage high schoolers and kind of motivating them. So year after year, when they come back and be participant in the contest, they can see the improvement, or like they get more engaged with it, with the computer science. I guess that's the whole point of having this contest. That's why it was introduced, so that students who are interested in computer science can come back year over year and see their improvement.
I would like to just add a note. Everything that the panelists and organizers said is correct, exactly that. But I think part of this is also trying to see if you can use games to learn yourself and grow. NSF, like North South, what it provides is a wonderful avenue. But what you will also gain from challenging yourself, and all the panelists have been excellent in sharing resources that you can go practice on, that becomes part of the gamification as an exercise and improvement, or self-improvement rather.
Thanks, Sri. Thanks for chiming in. Sorry, we didn't introduce you. So
Yeah, I was going to say.
Missed that.
Yeah.
No worries, but thank you.
Yeah.
Right.
Yeah, I will start with the questions. Krishnan, you can direct it to whoever you want.
Yeah. Okay.
One is, what advice do you have for the people preparing for USACO? Like how would you recommend preparing?
Pranav, you want to start?
Sure. So I would say with USACO, it's a lot of problem solving that you have to do. So like I mentioned in my slideshow, you want to first start off by mastering a language. What I started off first was with Python, but I would actually say if you were interested in getting involved with competitive programming, you need to know either C, C++, or Java, preferably C++, because C++ and C are very fast languages. And speed is extremely important when it comes to competitive programming. Java is a little bit slower, and Python is just way too slow if you want to do any major competitive programming. So maybe for USA Computing Olympiad bronze level, you'll be okay with using Python. That's what I did. But then if you want to do after that, like silver, gold, platinum, you need to switch your language. So yeah, I would definitely recommend getting started with those. And then to practice, there's a lot of sources that I mentioned as well, like the CSES problem set. There's HackerRank, LeetCode. Those are pretty good for getting you like started. And then there's also USACO's training guide that they have on their website. There's an official one made by the USA Computer Olympiad. It's called the Training Gateway. And then there's also an unofficial one that is the, I think it's the most popular one that's used among students, called USACO Guide. It's very helpful to help you learn more about the concepts that you need to know, like greedy algorithms or maybe different data structures, things like that. So take a look at those resources, and you do need to practice a lot of problems. So thankfully, USACO does release all of their problems on their website. So I would just say go through all of them as much as you can, whichever division you're currently preparing for. Just keep practicing them, maybe even practice a division ahead of that. And that'll really help to make sure that you are doing well there. And whatever skills you learned for training for USA Computing Olympiad, you can definitely apply in other contexts. Like, for example, I think the Lockheed Martin competition and then American Computer Science League, you can apply it there. And then these will really help you when you're going to start doing interviews, like coding interviews, when you are in college or you have graduated college. So definitely start picking up these skills now. And a lot of resources that we've mentioned, definitely take a look at those.
I think all of you have participated in USACO, right? I remember, Bomik, you were having some suggestions, right? In response, can you also relate how the North-South Computer Science B, helps or matches up with USACO in terms of how the contests are held?
Yeah, sure. So, I mean, last year when I took the NSF Computer Science B, I think it was really beneficial towards USACO prep as well. because the problems are very similar in that although the language may not be the same, where in NSF it's Java, whereas in USICO you might use something else. The main point is the algorithmic thinking, right? That's the main focus of the contest. It's, can you come up with the solutions, and not just some solution, but the best possible solution. And yeah, doing NSF really helped me start thinking in that mindset. It gave me a lot of practice and gave me motivation to continue with that. NSF also offers some prep classes for the computer science fee, so that is also something you can look into. But yeah, it's mainly about understanding the ideas, and coding is just a tool that you can use to implement your ideas and your solutions into an actual program. And yeah, NSF will greatly help enrich your thinking in this manner, and it'll start to make you understand more about the problems you're trying to solve.
Anybody else want to comment on the USACO preparation? Go for it, Satvik.
Yeah, so as part of what Bhumik said, that although the NSF contests don't have actual programming challenges, it increases your mastery of these languages, and that's really important for competitions like USACO, and also being able to look at code, know what it does, and just another side note is between USACO and the NSF computer science competitions. I think one place where the NSF computer science fee is actually really good is that it also covers other areas of computer science, like hardware and like web development. And though, because as you do USACO, you get exposed to this one area of algorithms, but for example, like when you go to college, even if you specialize in algorithms, you usually end up taking courses like in other areas like hardware, and being able to have that foundation is just better and makes you a more complete programmer. And in terms of preparation for that, a nice place to start would be maybe like the AP Computer Science Principles curriculum. But if you look on the NSF website, they also have a sort of curriculum that has some topics that you could look at.
Anyone else?
Yeah. So like, I think that the fact that North-South, like, the CSB is like a potpourri of different like debugging techniques versus like structures and general things that you should know about like computer science. Anything that you do in preparation for like any other aspect of computer science will inevitably help you like do better on the NSF CSB and vice versa, right? So if you're going to learn about like general CS techniques, they're going to help you in like USICO or like even anything else you might do, like web development or app development or something like that, right? So like they complement each other, and doing one will like give you more experience generally, which will help like you do any other thing in CS.
Great, thank you, Shreya. Let's go to the next question, Daisy.
What is the minimum math level for 6th grader to getting into the algorithms for CS? I mean, an allegory question from me also is it, what is too young to be getting into the computer science? Is there a such thing? Yeah, go ahead, Bhumi.
Yeah, I think if you're just getting started with computer science, you actually don't need too much math knowledge. I mean, learning syntax, learning languages, this is more of a change in perspective. And it's just about getting used to the idea of computer science, how computers work, how you write something and a program actually executes it, seeing your first Hello World program, it's really validating. But in terms of math, you typically start needing this math once you start to develop or dive into specific categories. So like if you start pursuing machine learning, yeah, then you're going to need some knowledge of calculus to understand what's going on. Or let's say you're doing some statistical modeling. You're going to need to know some statistics. But these are all applications of computer science. And there are many applications where you don't need too much math either. For example, in competitive programming, it's fine if you don't have knowledge of calculus or anything too advanced. The main idea is thinking in a different way and understanding the concepts of algorithmic thinking.
So specifically to talk about like how you might like go about learning like maybe algorithmic thinking as a sixth grader. As Bamik said, it's not a like question of like, are you too young? It's like, how comfortable are you with like doing CS and like working with CS topics? So I just said like write some, I don't know if you've written programs yet or whatever, but like write some programs, have a feel of like how your program executes and if it's doing it efficiently, like if you think there's some slack in how you like get your answer, and also like look at how other people write programs, and if there's a difference between the way you write programs and the way other people write programs, you might want to figure out why. And that's often like the like a core thing in like algorithmic thinking, just like how different like ways of solving problems compare to each other. So like just get started with that, and then like if you look online or if you do like north south, then you'll inevitably be like exposed to different other resources that you can use to get into those topics. But yeah, and as other people said, there's a lot of like courses that you can take, specifically if you want to get into like algorithmic thinking or whatever. So yeah.
So I think in the beginning when we had the poll questions, there were a large number of students in the 6th to 8th grade in the session, in addition to all the high schoolers. So I wanted to rephrase the question and get all of you panelists to answer the three things. What was the first program you ever wrote? When did you do, and what language did you use? Okay, the first program, when, which grade or when you wrote, what language, and a little detail. Go with that, Pranav.
Does Hello World qualify?
Yeah, I think that is perfect. The way I looked at Hello World is either you could have done it as a compiled program or an interpreter. In an interpreter, it is like print Hello World, right? You're done. You got your first one. But when I talk of programming, you wanted to have your first real program, as you would call it, as something executable. Okay? Go for it, Pranav.
So I would actually say my first program was not in a text-based language, so it wasn't Hello World. I was instead using Scratch. So my first program was making a Scratch sprite move around the canvas. So that was pretty exciting. Like if I move the arrow keys, I can see how the cat, like that main sprite, is moving around the canvas. That was pretty cool.
What grade were you when you did that?
I think if I remember correctly, this was first grade or kindergarten. I think first grade. I think it was first grade. Yeah.
Okay.
Yeah, I mainly did Scratch until like the end of elementary school, and then from there I transitioned on to the next few languages. But,
okay.
What was your other question?
No, I said application. I think you covered it. Let's go to Shreya.
Okay.
Go, Shreya. Remember?
Yeah, so I don't exactly remember. It was perhaps a Python program because I don't know. Or it could have been like there's this thing called a Terrapin logo that like draws lines using a turtle. It could have been either one of those, or it could have been Scratch. I honestly do not remember. But I didn't really get into like programming or CS until like maybe like 8th grade, and even then it was like not like serious. Maybe I started doing competitions in 9th grade, but yeah.
That's more
So
like it.
yeah, but yeah. So in terms of first program, it was probably one of those three things.
Bamik?
Yeah, I think the first program I ever wrote was in 4th grade. My dad was nudging me to learn CS. and I wrote a simple Hello World program. But similar to Shreya, I didn't really start applying programming until, let's say, 7th grade, when I started getting into competition math. And yeah, I think like all of the experiences that have been shared just go to show age is just a number. It's up to you as to when you feel ready to start, and you can do it. And it's really exciting and fun to have a program work and see it execute.
Satvik?
Yeah, so I think as Pranav said, so my first like program was in, I think, either Scratch or for those of you know code.org, they have, it's kind of like a programming with blocks. And I think this was around like maybe like 2nd or 3rd grade. But then in terms of like actual programming languages, I think around the end of elementary school, the first like basic program I wrote was kind of like a number guessing game with Python. And then I think just building off of that, like my first like major project that I remember was, I think, in middle school, like 6th or 7th grade, and it was basically like a minds. For those of you know, I think Mastermind. So I coded that in Java. So I think definitely at a young age like that, building projects, right, and having that motivate you, like, looking at it and being like, I coded this, I think that's really a big motivational factor.
Yeah. So go ahead, Sri, if you have anything to offer.
Yeah, I want to bring a slightly different perspective, but basically I'm endorsing all the panelists and everything that they've said. In my professional role, I lead a bunch of data scientists. By training, I'm a statistician, right? And outside of all this, what I also do is I am a coach for a local robotics team that participates through FIRST and others, right? So the panelists are nodding, so I'm not off the path here. So thank you. What I am going to say is, again, age is just a number. You all said that, you all endorsed that. What I would also say is, if you're interested in robotics, that's a good way to stepping into thinking like a programmer, because what you're essentially trying to do is trying to convert your thought into logic that somebody else, in this case, a machine, can understand. And you are never too young. When my first team won the regionals and they actually got that machine learning award for programming at the Worcester Polytechnic, most of the team was 6th grade to 7th grade, right? Almost entirely the team was 6th and 7th graders. There were 8 of them. I think there was one person who was like an 8th grader, but the 6th and 7th graders did a bunch of the bulk of the coding, and they won an award for programming. So I'm not saying I'm responsible. I'm just saying I had a bunch of really qualified kids, and that did help them mold into future, computer science geeks, right? The positive way.
I definitely agree with you, Sri. When our little kid was like 4th grade or 3rd grade, I had them start on the QNX toolkit with Lego, so they can spot abstractions and move around. So getting that logic thinking early in your preparation will definitely give you a heads up, and leaps and bounds you can progress when you learn actual programming and coding.
Absolutely. And most of you may already know this, but the robots that they use are from Lego. It's the Mindstorms, the EV3s, the unit.
Right.
In the back end, it actually does Scratch. And Scratch, I think 3 or the 4 of you mentioned it anyways. Right. So I would definitely recommend that. And again, don't stop yourself because you're in 6th grade. You can do everything.
Great. Excellent. Any next question, Daisy? Anything?
Yeah, an extension to Sri's thing. There's a question that is game development a good way to get started? Anybody?
Scratch is game development. So yeah, sure.
Yeah.
It is also very challenging, though, not easy to do. So I don't want to trivialize it, but you guys answer it.
Yeah.
I would say with Scratch, if you want to do game design, that's honestly the perfect way to get started, because especially if you're young, you want something to get you interested in computer science, and creating your own games. Like you're able to play games and all, but then being able to make your own games and see how they work, and then understand what goes behind game design, like even elementary game design through scratch, is definitely something that would inspire you to pursue computer science more in depth.
Yeah, so I want to clarify, like, I'm not talking about like making Fortnite. Like, that's not like an introductory level thing that you want to like set as a goal. But like, for example, my brother, like, a definition of game can vary widely, right? So my brother creates Scratch games now because he has that in school. And so his game is you have to like click on a broom that clones itself like every time you click it or something. And he has fun with that, and it's like a game. Then he likes programming now, so go for it.
Yeah, I think another thing with game design is it'll really help you, as Pranav said, like understanding what your game is doing, the concepts behind how you structured your program. These are all very important, and they're going to directly transfer into other programming constructs. So yeah, game design is a great way to get started, and it's another really good application of computer science.
Satvik?
Yeah, so basically, as I said, right, when you're making a game, there's obviously different levels. Like there's the kind you can make on Scratch, then there's the kinds you can make basic ones in like Python or Java, C++, and then there's obviously like the higher level ones, like the kinds you make as an actual game developer as like a career choice. So I think in terms of when you're getting into computer science, making games is definitely a really good way to motivate yourself, like Pranav said. And if you're looking at as like a career choice, that's just another branch of computer science, like web development, algorithms, machine learning. It's just one of the many things you can do.
Thank you.
Okay.
We have last few minutes, so maybe we take one last question there. Desi, if we have.
Yeah, one question which, of course, Vinay had already answered, but how long does it take to prepare for the competition? As an intermediate coder, would it be too hard to learn what's needed before the contest date? So
I would say first sign up, because then you'll have the motivation to do it, even if you don't think you have the time. But secondly, if you're an intermediate coder, you probably know like generally how to debug or like other general concepts. So like preparing for the North-South B is probably not too different from what you're already doing. So go for it.
I'd say another really good thing about the NSF CSB is that it targets many different areas. So it's not just about languages. There will be questions about, networking and how other computer science concepts work. So if you're an intermediate programmer, yeah, as Shreya said, sign up. It'll give you the motivation to get started, and try seeing what general concepts you are not sure of. There's a list of topics available online as well. But yeah, just go in there and see which ones you need to look at more, and then just investigate and explore. You can do it.
And a lot of it, like Bhaumik and Shreya said, is debugging. Like a lot of the problems are related to that kind of category. So I would say the best way to prepare for that kind of thing is not only just learn the new concepts, but look at what happens if you change certain parts of code, what kind of errors you get, all of that, because it really helps to improve your debugging skills. And it's definitely something that you not only apply in the North-South Foundation, but something that you'll be able to expand when you work as a software engineer, maybe at some company, because you might be doing a lot of code reviews, you might be fixing code that went wrong, or you might be creating new code. So things like that are really, those are something that can be helped by this kind of practice.
Yeah, and as Pranav said, right, debugging is definitely a large part of programming, in my opinion, because one thing is being able to know the syntax and write a bunch of code, but then once you have, let's say, like lines upon lines of code, being able to debug it is often a really, really useful skill, and it's actually sometimes even harder than actually writing the code, especially when you have a lot of code, you need to figure out where your code is going wrong. Sometimes, right, you could spend hours trying to figure out what's wrong, and then you find one line that, or even like one character that could have been the difference between your code compiling and giving an error. And I think with NSF, there's a lot of questions designed to help you look at specific parts of code and figuring out, different ways you can do things or figuring out what's wrong. And to get better at those kinds of things, one thing that's really helpful is just doing a lot of programming yourself, because as you create and like develop your own, piece of code, you'll start to see, places where you can improve or places, common things that go wrong. And then looking at code and figuring out what it does will just become like a secondhand thing to you.
And I would also like to add that why don't you consider this as your starting point, basically, for your computer science journey? Why, like, there never is going to be a good time or better time. Okay, I'll do it next year. No, just take it as a challenge, do it. It will motivate you and it will help you in preparation for the AP computer science exam also, because the curriculum for this contest is AP Comp Science. So just go for it. It's like gamification. Not this year, yeah, you at least tried, and next year you'll do much better. It's a win-win situation.
Yes, definitely a big motivator to do well in school as well as to do well in other competitions. One advice, Anju, I don't know if you can offer to the contestants. Most of the questions provide some piece of code, and it is very easy to get distracted and see what the Python code does as opposed to what the Java code does. And how can we help people not get distracted and spend time? At least that was my challenge when I looked at the question paper or contest paper.
But Krishnan, the thing is, we are not taking the test, right? So students who are taking the test, they don't have that much time. So they will have to focus on one particular language, so Java or Python. The syntax, there is syntax difference between both of them, right? And so if they have to actually complete the contest, the exam in those 45 minutes, they have to just focus on one. I don't think so it's going to be that difficult.
Okay.
Yeah.
Anybody else in the panel want to?
Yeah, exactly. They took the test, so they know more.
Yeah.
I will say take like a practice test so that you can get that all out of your system. That's definitely what I did. So as soon as I had 3 problems where with both Java and Python code, I was like, okay, this is old, and then I moved on.
Sri, you want to say something?
I was kind of going to endorse that as well. The approach that Anju just mentioned, focus on one language. I am part of the core team as well, so we set the questions for you all. And when we do that, we make sure that everything aligns, even going so far as making sure that the lines in the Java and Python kind of come across same. The images are identical. So we are putting in a lot of effort to make sure that you get to focus on what you need to. Pick whatever you like, Java, Python. Sometimes maybe one doesn't give you the answer, and maybe you're comfortable with the other one, just go with it. You don't have to choose which language. We don't ask you which language you chose. The answer will not change no matter which you pick, right? All we want is you to answer. And the one thing I'll call out, I know we are at the end of the time, is if in doubt or if you do not know what to do, just pick some random answer. There are no negative points, okay? I'm not saying this because I don't want you to be successful or that I want you to be successful even if you do not know the answer. I'm just saying it's a test-taking maneuver, right? This is gamification. Let's try it.
Great, thanks for that suggestion. Anybody else? I don't know. Satvik, you were raising hand, or go for it.
Yeah. Okay, so this is kind of related to some questions I saw, but I think a lot of people are wondering, given like all these AP classes, sometimes your school is restrictive in that sense, and I've experienced that my school is also badly restrictive. I think I only took AP Computer Science A and Principles in my junior and senior year, even though those concepts I already learned many years in advance. So I think a big thing with computer science, I think Bob said earlier, is how you need to, if you have the interest, there are tons of resources online where you can learn the exact same information that you would get from all these AP courses. And you don't necessarily need to wait up to go with your school's curriculum. One reason, obviously, why they might be useful is with the getting the AP credit. And one thing that you'll find is learning all these concepts beforehand right? Like for example, if you learn Java like a year or two before actually taking AP Computer Science A, well, you'll have that knowledge already where you could have been, you know, working on projects the whole time. And when you take the class, it'll be really easy. And yeah, so if your school is kind of restrictive, you don't necessarily have to, you know, wait. You can just go right ahead, use the resources online, and, you know, progress and, you know, make projects, participate in competitions, etc.
Okay, I think we are getting close to the end of the hour, our allocated time. So it's been a privilege to moderate this panel. Thank you all panelists. Really enjoyed it. And also you are a real star example of the learning journey where you have taken the contest. Now you're giving back to the new students who want to enter into this contest. So thank you so much and continue excelling in your endeavors. With that, Desi, back to you.
Yeah, thank you, Krishnan. Thanks to you, all of you, and thanks for the audience. I hope you found it as interesting as I found all this information given to us is. We will try to send you all these links and the information be presented to you tomorrow. I thank all the pros for your time, your effort, and also your patience in answering all the questions. And I want to thank Anju and Sri for their time and helping us, and Vinay, of course, in the background helping us with answering all the questions, and Krishnan for moderating the session. Everything looks good. Like I said, this is a new contest we have starting in the regional level. I would like everybody to just put your feet in and then wet your feet so that you can get into that topic. Thanks again for everybody. We are planning to have another interesting webinar, MTP webinar next week, next Sunday, February 27th at noon Eastern time. This time it's going to be on history and geography pros. So please plan to attend the webinar and meet all the pros and converse with them. Please wait for our email. We'll be sending it to you shortly, and then register and also attend those webinars. Thank you for your continued support, and stay healthy, please, and stay safe. And we would like to see you right back next week.
Thank you.
Thank you so much, Desi.
And good luck to you guys. You guys have done so much already, you know, so I don't think you need a luck, but I all wish you a great success. And Shreya, thanks for all the MTP webinars you have been flowing through all this time. Thanks for your time, and good luck at MIT.
Thank you. Bye.
Thank you. Bye-bye.